asked in the chat box.
Okay, चलें ठीक है, Dr. Saab, I'll get started. So, thank you, Dr. Hassan, for this opportunity, and also Dr. Arshad. I've been working with Dr. Arshad for about 4 years, actually, since I moved back to Pakistan. So my topic today is microelectronics ecosystem and opportunities in Pakistan. So I must say it's a big topic, so I'll try to do justice. And I feel that there's probably too much to talk about, so I'll constrain myself. But if you have questions, then surely you can raise them, and I'll try my best to answer. Let's go take a look at the agenda. So I'm going to talk about the microelectronics industry. Actually, that's going to be a very sort of quick one on that. My big focus is going to be on the semiconductor industry, but they are obviously, as we say, joined at the hip. I'll talk about the ecosystem. So there are obviously many ecosystems that are we have studied during our school years. Likewise, we have a very robust global semiconductor ecosystem. I'll talk about that. I'm sure a lot of you on the call today and in this meeting and throughout the sessions today and tomorrow will be looking for opportunities. And opportunities are not just for new graduates. They can be people who have already got some industry experience, or they are in the academia. They want to go to the industry, or industry people want to, wanting to go to academia as entrepreneurs who want to start up new business. So I think there's a whole lot of opportunities there. I'll briefly talk about my company, Tech Solutions, which I've been running for a little over 2 years. The key thing would be, what is the takeaway? Because in my opinion, it's very, very important that we follow through on certain things, and there should be something concrete that we get out of these sessions, given that all of you who are attending this, taking time off to listen to these presentations and speakers. So I'm hoping that everyone will take key things from my talk today. Okay, so let's start with the microelectronics industry. It's obviously no surprise to anyone, I'm sure, in the audience, that it is a centerpiece of the world we live in today. Everything we look at pretty much everything we look at has some shape or form, some electronics behind, and this is a $3 trillion. So one thing is that I will try not to focus too much on numbers, because I think then sometimes the message might get lost. The big thing is that it's a huge piece of the global economy, trade, technology, all areas. It is connected, and it's obviously has got massive impact and bearing on the geopolitics of today, the economic landscape, industry, all of that. So on the right hand side, I'm showing some of these slides. This graphic, basically what it means is that the chip and then the system, which is embedded systems or high-end systems, or which are in the automobile side, which is a very, very hot area right now, which can be AR, VR. It is in biomedical, it's in defense side, it's in telecom, it's everything, right? So all of that are driven sometimes with some just sensors and not maybe intelligent sensor maybe, but a lot of times any substantial system has some device or a controller inside, an SoC. So this has actually resulted in the last I would say about 10 years, there is this so-called chip war going on, and this is not a name that I came up with, but this has been documented, this has been reported, this has been published a lot. I'm sure most of the people on the call know. We'll talk more about it during the course of this presentation. The other part is that it's not just technology and it's not just economics, they are also interconnected. And people are worried about the infrastructure, about the security, and obviously a big part, as engineers or people from the technology world, there is obviously this leadership, which brings a lot of other benefits and economics and other areas. And then there are trends, like all industries. We also have big trends ongoing, and I'll talk about those, whether it's miniaturization, whether it's AI, whether it's some of the other factors that are playing into the semiconductor industry. Let's move on. Yeah, so the interesting part is that this microelectronics industry is driven by a very strong semiconductor industry, which is, again, these are the sensors, these are devices, these are chips, logic, memory, all of that. It's about 600 billion strong. So, again, big numbers. I promise I will not talk too much about numbers, because then people might get distracted, especially in Pakistan. I guess we pay a lot of attention to billions these days. Okay, so on the left-hand side, it shows the semiconductor market. So we have got different segments of it. It has got a big memory component. So any modern chip, a lot of times, can have 50% of the area taken by memories, or sometimes even more. Then there are other micro components. There's optical devices or other special devices. There's obviously a big analog component, and the logic part. And actually, for my vested interest, my focus is in a big way towards the logic side, but I will cover in general. On the right-hand side, there is this table that shows some of the top players: Intel, Samsung, TSMC, SK Hynix, Micron. Interestingly, of the top five, Samsung is into memories, SK Hynix is into memories, Micron is into memories. So that just sort of, highlights that how big the memory market is. But then Intel and Samsung both have a huge presence, especially Intel on the microprocessor side, more so on the high-end x86 series and so forth. In the second part, 6 onward, there is Qualcomm, Broadcom, NVIDIA, TI, so forth. So all I want to share with the audience is that it's a very big industry, a lot of big names that we are very familiar with. They are part of this, and their revenues are from 70 billion to 30 billion dollars. Again, big numbers. And my vested interest is also in RISC-V. So I'm saying that a lot of these top companies are also engaged with RISC-V, and we'll talk more about RISC-V down the road. Okay, so yeah, a lot of things have changed since the semiconductor industry started, let's say in the late 50s. But the fundamentals are the same, which is innovation. It's building up ecosystems. It's serving the markets. It's, basically, what is the problem that we are solving? So I touched on geopolitics, but the fact is that semiconductor industry is a very global industry. It's not just, restricted to one area. If the raw material comes somewhere from Japan, goes into USA, where there is a design work done, and some of the other work, a lot of companies, the model they are using is that especially the ones who are based or headquartered in USA or North America, that they have key people in USA, but then a lot of their workforce is globally placed. So they do some of the design work. It goes back to the foundry side. Let's say that it's a global team. Many people are working on it. When the chip is put together, or some other product, it goes back into, let's say, Taiwan, TSMC, and obviously is the largest foundry. And there are other players there as well. Samsung, Global Foundries in US. But right now in Asia Pacific region, about 90, maybe even 95% of the chips are being manufactured in the Asia Pacific region. It can, once that is on a wafer, it's gets tested, get into China for manufacturing. And that actually brings up a lot of other questions so this model, or this sort of picture that I'm showing, this is not new. It's been going on for many years. And I'll talk about some of those factors as well. Okay, so one question that comes up is that, yeah, I mean, especially maybe for Pakistan, because what's the pressure to build chips? People on this call, I'm sure, are looking for opportunities. I'm sorry. Whether they are job or they are looking for business, you know, looking for exchange investment. The other part,
I think Dr. Jafar has lost his connection, so let's wait for a few moments to let him establish the connection again. Meanwhile, any question from the audience?
sure, sir.
Although it's just
Okay, I think I lost the connection for a
yes,
second.
yes.
So,
Welcome back,
Dr.
sir.
Hassan, should I just start from where I
Yes,
was?
yes, you just continue.
Okay. Okay. Yeah. I was
Sir,
I was on this slide, so I hope
Mr. Jafar,
everyone.
your slides are not visible. Kindly share the slides again. Sir Jafar, are you online?
जी, uh, so Dr. Hassan, I don't know कि कहाँ पे वो मसला आ रहा है जी. I can hear you.
Sir, your voice is also clear, but slides are not visible from your side.
I think कोई सिग्नल का इशू है because आपकी आवाज काफी muffled है.
Sir, kindly share the slides again. I think Mr. Jafar has some issue about connectivity. So let's wait for a few moments to getting his connection to be stable. Meanwhile, any question from the audience? Okay, so before the connection issue, Mr. Jafar was talking about the ecosystem of the IC design that is globally. So all of you have seen that actually once the ICs come as a product, it's more or less it circulates around the across the globe. It start designing from the somewhere US, Europe, or somewhere in the Asia, then travels for the fabrication to the mostly to the Taiwan TSMC, then again for the packaging and further processing of verification it sometime or testing, it goes to the other countries like the Vietnam and Asia Pacific regions. So that is the complete global cycle for the production of the ICs. So I think Mr. Jafar is back online. Sir Jafar, can you hear us?
जी, Dr. San. So I'm
Yes.
back. Actually, network का तो मेरी तरफ तो I don't have any issues. I don't know okay, why it's
Okay.
happening.
So now its connection is safe, the established again. So kindly you can resume from the same point.
Yeah, I'm about to.
Okay.
Okay. Yeah, so I think I've gone through these three main areas that why chips are important, why associates are important. So another factor related to it is that what are the key care abouts? So uh, there are four factors listed here: efficiency, cost, thermal latency. So when we say efficiency primarily because
Mr. Jafar?
these things are actually needed.
Mr. Jafar, sorry to interrupt. We are looking at slide number 6. You are at slide 6 or some other slide? Mr. Jafar, can you hear me? Mr. Jafar, can you hear us?
Gee, I can hear you. Uh, let's problems. I've been on the same slide for some time now.
Yes.
So maybe it's an issue on my side. Um, Dr. Wait a second, maybe
Okay.
let me try if this is a problem on my side. Actually,
Okay.
network shows fine. चले, मैं फिर let me start again.
Okay. Thank you.
Okay. चले, okay, so I was mentioning this part
Sir
that
Jafar?
efficiency, cost, thermal, and
Sir,
latency requirements are.
Sir Jafar, I think
G,
there is issue about the bandwidth. Better if you turn off the camera. It would be better. So might help to relax the bandwidth.
G, चले. Okay. Uh, okay. चले, is this better, Dr. San?
Yes. Now
Uh,
it's better.
अच्छा. चलिए, so let's talk. I mentioned efficiency, which is also related to power performance area. Cost, obviously, whenever a product is brought in, that's same is true for a chip. uh, you have to look at the cost because there are existing players, unless you are in a very, very niche area where you can, you can get very high costs. It's even then you can get the market share. there are some products, but I think increasingly it's very, very critical that you keep the cost down. Thermal issues are not just at restricted to device level; they are system level challenges. But if we look at just from a transistor standpoint, it can be just the junction temperature. From a chip point of view, it's package, it's the skin temperature, all of that. And I'll talk a little bit more about the thermal issues. Latency, about 10 years back, a lot of times the industry was driven by faster clock speeds in terms of gigahertz and so forth. But increasingly, people have been focusing on, especially the big players as well as other players in the market, which is looking at latency and obviously the movement of data between, let's say, a CPU or a controller or microprocessor and the memory and the whole system and the IOs. So it's the overall latency or the throughput of the system that's also critical. I just wanted to share, because I've mentioned a lot about SoCs and many people on the call might be familiar with it, but I just wanted to show sort of a block diagram. This is shown on the left-hand side of the screen. So a chip or an SoC has many components. So I've just shown sort of these blocks here. So the blue one is shown as AMS, which is the analog part, can be custom IP. For designs, there are a lot of mixed signal designs in which, at the chip level, if there is logic at the top, then the analog portions are brought in as macros. They are models which are instantiated and modeled and laid out. And then the other part is the digital, which actually I've maybe a little bit more focus here. The green part towards the bottom of the chip. So there are processors. A lot of times there are multiple processors, dual, quad. Actually, you might be familiar. Esperanto recently taped out a chip with 1,000 processor cores. Actually, that trend has been there for some time. It's not a new trend, but obviously you have a lot of processors depending on the workload and the target application. And then there is an interconnect. So when I talked about the throughput and latency, that brings up the criticality of the interconnect and how it's getting connected to the memories. And the other part I'm trying to show in the bottom part of the slide on the graphic is that what is the differentiating thing about this chip? Why is this chip needed? And what market it's really targeting. Okay, so these are sort of the key things as far as the main part of the diary of the chip is concerned. But then this has to talk to the outside world. So all these boxes, which are red and gray around the periphery of this chip, it's obviously just a block diagram. There are many different IPs listed: high speed, low speed. It's not as if that every chip has all these, and it's not as if that every chip will have all of these pieces in it, but this is just to give an example that for talking to the outside world, it will have some low speed peripherals like an I2C or an SPI. It can have some high speed Ethernet. It can have SerDes, PCIe, USB again for high speeds. A lot of sensors which are talking to this chip. So all of that, they make a chip. And down the road, when I talk about the ecosystem, you'll see some more details about it. So actually, this was mentioned briefly before, but again, the cost and overall market needs really drive when a chip designer or a chip architect is looking at how to design a chip for the specific market. Some new trends that have come up in the chip side are, so there are a lot of them, like power, performance, have been there for a while, but safety, security, AI, ML, these are some of the new trends, and safety has become a big player or big consideration for automotives and AI-enabled automotives as well, whether they are ADAS chips or their infotainment, or in general, even other controllers. There are about 150 controllers on modern cars. So safety and longevity and aging effects of devices all come into play, and there are very stringent rules for that. security is also a systemic problem. It's not just one part. It's from conception of a chip all the way when it gets into the system. All of that has a security dimension as well. And then AI ML, which has become a big part. Obviously, it's very prevalent in the society. I mean, in the technology part, there's a big software part of it. But in my presentation, I'll talk a little bit that there is a direct relationship with the hardware as well. And it's not a surprise that Synopsys, Cadence, Google, NVIDIA, many players, top level players, we can pretty much talk about anyone right now in terms of Apple or Amazon or Meta. All of them are doing AI ML, and there are a lot of startups in this space as well. So one other thing that many in our industry are familiar with is the Moore's law. I guess the good news is that although it has slowed down, but it has transformed, or it has sort of morphed into other areas. So if I say that, in the 70s, it was a lot at the transistor level. Now, and then it moved to gate level, RTL level. So level of abstraction kept changing. And then the IP level, when, in my previous block, you must have seen that these are sort of building blocks. If it's like a Lego, that, if you want to build a chip, or, if Tesla is making a car, they don't make everything that is in a car. They make key parts of the car, which is battery related, which is related to the ADAS or the autonomous cars or infotainment. So other further pieces they just pick up from the industry. So same is for a chip, that if someone is building a chip, they don't design things from scratch. They pick up a lot of IP, intellectual property or blocks to build a chip. And obviously one key reason for that is designs are much bigger, and you want to bring your chip to the market as soon as possible. That's how you'll make more money. The latest trend is chiplet. So this is also, so you can see that things which are planar on the transistor level or at the system level, at a system, still at the chip level, now we are going in 3D. It's not a new trend. It's been there for like 15 years, but it's picking up steam, and Intel, AMD, all are talking about chiplets. And that's another presentation itself. So the key thing is that what all the analysts believe, or people who follow the industry, is that what we were seeing previously, let's say about 15 years back, was a lot of the device level or transistor scaling that was happening. They were the driving force, but then they ran out of steam. Then we came into the multiprocessor world. A lot of software changes came into part, threading, multi-threading, throughput, and then pretty much most of the people believe now that it's moved to the system side. And for the system side, some of the things are the same, but in terms of thermal considerations or power considerations, they are still there. But overall efficiency or energy management is a key factor. Transistor scaling has slowed down, and the cost has gone up. So Moore's law in that sense is not really the same. Density is still increasing, but there is an increase in cost and power. Litho has become a lot more complex. At 3-5 nanometer, we are talking about very complex litho equipment, ASML and others, and Lam Research, others are playing a part. But it's expensive, it's complicated, and clock frequency has been sort of stagnant. But since we are looking at the system level, we are not really nitpicking on specific areas only. So another part which I mentioned earlier on is AI, and along with that is RISC-V. And I'll talk more about RISC-V. This is an open source architecture that I feel is an opportunity for Pakistan, and some of the companies in Pakistan, like ours, is focusing on RISC-V. There is a prediction that there's going to be like 25 billion RISC-V based SoCs or AI SoCs by 2027. There is a lot of data on this. It's already playing a big part on the hardware side, along with software. Obviously, the workloads that are being developed and optimized for the hardware, they run on hardware. So obviously, it's a there are many layers, but the bottom layer is hardware. which is playing a critical part. And it's expected that by 2027, this market is going to be 85, 95 billion. Overall, AI, and many people on this call might know this already. They, they must have seen that some people, analysts believe that 2% GDP growth worldwide can happen because of AI. So I will actually focus more on the hardware side and the design side. So on that, so this is maybe a quick jump. So I apologize for the people if they're not very familiar with the manufacturing side or the SoC side, focusing on the design side. So this is a complex sort of graphics here, but what it's showing is that there are a lot of challenges that were happening because of miniaturization of the devices, primarily transistors, and FinFET, and then many versions of FinFETs and gate all around and complementary FETs and so forth. But some of the things that are happening there are related to, again, power or electromigration. It's also related to manufacturability. It's related to the design rules. It's related to placement. It's related to patterning. So many things. And again, they are a little bit more centric towards chip design. But that's sort of my area of expertise. So that's one of the reasons. But I'll try to then abstract a little bit that how AI can help in some of these areas. So again, so this slide has got some graphics on the top left-hand side. So again, the cost, time, and expertise. I think those are the challenges which are very, very prevalent in the industry. And where AI can help is that reduce the cost, reduce the turnaround time. So design cycle of a chip, if it is, let's say, it used to be like 4 or 5 years, it has been shrinking over the last 15 years. A lot of companies have 1 to 2 year design cycle. If it's a rev, it can be faster. But in all of these areas, AI has become a very significant factor, and I'll talk more about it. The other part is expertise. So one chip can typically have like 14, 15 different experts in their areas, from microarchitecture all the way to DFM and testing. The graphic in the which is shown as one, I apologize, the fonts are too small, but it actually talks about clocks. It talks about library cell selection. It talks about IR drop or electromigration. It talks about floor plan. So floor planning is a very key part of the design cycle. And floor planning is a stage where a lot of iterations are done. So a lot of you on the call would be aware that anything that is repetitive, that's a great source, that's a great target for AI. And whether it's a reinforcement learning or it's a DL or ML, all of that are playing their part into it. And it's also at the microarchitecture level, it can be that how can different configurations of a processor or memory be quickly simulated and tested. This graphic, which is shown as number 2, is actually NVIDIA. So this is an NVIDIA chip in which they have got these hundreds, in many chips, you can even see thousands of macros. So in the floor planning stage, you can easily spend months trying to get the best floor plan, an optimal floor plan, with many designers working on it. With AI, and actually they use some open source in this for this experiment also, and it's documented, it's available. They have been able to cut down by months their schedule. And it's not just one company, this is across the board. That AI ML has become a big part in terms of power optimization, in terms of actually even DFT or test coverage and testability, in terms of cell placement, in terms of design rule fixing. On the right-hand side is a graphic from Lam Research. So this is a company that makes a lot of the manufacturing equipment. So they literally have to try, this is again documented. It runs into billions of different formulations they can have. This is for plasma etching. And based on their experience, the number of chips they have done before. And it's the same for chip companies also, but on the manufacturing side, they want to get to the best recipe as soon as possible. So they are also using AI. So this is actually just sort of a quick snapshot. And I wanted to talk a little bit about it because AI is the focus of this conference as well. This is actually the end of my first section, but I just wanted to give all the electrical engineers, computer engineers, CS graduates, that there is a lot of opportunity. There is shortage of qualified people. So you all have very bright futures. Let's talk about the ecosystem. So this slide was shown before, but I wanted to show here something different, that for each one of these areas which have become a center of chip design, from microarchitecture all the way to a product, a big ecosystem has developed in USA and Canada, primarily in USA, and within USA it's Silicon Valley, it's obviously Austin, it's Boston area, it's San Diego. These are some of the key areas. Another area that had an ecosystem, well-developed ecosystem, is the Asia Pacific region. And this is Taiwan, South Korea. Japan used to be a big player, but they're trying to come back, but they have slowed down. China is the emerging power here in terms of technology and manufacturing and all that. And that obviously brings up that other thing that I mentioned earlier on. So I've mentioned China as a separate one as well. And then EU. So EU, or European Union, has been on the lagging, but they are again making some huge investments, and talk more about it. So ecosystems are obviously critical to build up the scalability, to get more companies and to create jobs. So quickly, I wanted to talk about the semiconductor ecosystem. I will not spend too much time. Bottom side is IP providers. This is Akiana is the company that we work with at Akaltech Solutions. We are partners. We do their R&D work. Then it's EDA, electronic design automation tools. These two, I'm not focusing too much on it. Manufacturers and manufacturing related industries. Fabless is a big focus area, and we can talk more about that in some other talk. IDM are independent device manufacturers. It's like Intel and Samsung's, and the foundries, TSMC. You've heard their name a few times. There's obviously Samsung. There is SMEC from China, and Intel trying to come back again. So there is a little bit of a plugin for IP. This is what my company does. Intellectual property. So we basically design processors which are then plugged into SoCs, and there's a whole flow for this, starting from research, designing, manufacturing, assembling, testing, and distributing those parts and devices and systems. So ecosystem. So another ecosystem. So you'll hear this ecosystem. This is part of my talk too. So I think I'm sort of shamelessly using this a lot, but it's a fact. Every industry needs an ecosystem. I think for the audience today, my big thing would be, because a lot of people from academia, that there's a huge opportunity for academia to play their part in this 5 ecosystem. Even in Pakistan, this is a lot of universities have been working on it. So this actually slide shows that on the industry side, it's obviously the company I am representing, 10X, Dream Big, GSME, Impare, Comira, Rapid Silicon, Exilium, many players. And I'm very confident that there's a huge opportunity for more players to come. The big thing, or our challenges here, are that how can we scale? Academia, I think it's great that NUST, MERL in Karachi, with UIT Lahore, LUMS, FAST, in Islamabad, Beria, NAML, GIK, UET Peshawar, Qaid-e-Azam University, and many others. I apologize if I've missed any names, but it's really the industry and academia that we have a huge opportunity. And why? Because it's open source. We can use open source codes. We can also use open source tools. The best thing would be to get commercially dear tools, but if we don't have access, then we can, universities can start working on it. So since it's ecosystem, I just quickly wanted to mention these innovation clusters. I know people in Pakistan, some quarters in Pakistan are looking at it. I think, in my opinion, if I summarize, I'm not going to go through each one of them because they are from Silicon Valley to Europe to Israel to India to China to Russia. Many countries. The common themes are there needs to be good universities, and so these are some of the university names in these clusters. And the other part is that companies, some big names and even startups. And the third part, very critical, is the VC funding or the funding. And that's, the thinkers and planners in Pakistan need to think on these lines. I don't think it's a surprise for anyone, but I just wanted to show it with the audience today that, in my opinion, this is a key factor. Okay, I think if I summarize it in terms of the ecosystem, I think the key stakeholders are enablers. Again, if you look at clusters, if we look our neighbor across the board, if we look at other places like Singapore, South Korea, China, Vietnam, all of them, they've been able to set up these ecosystems very effectively. Industry is a big part because, for us in the industry, we want to hire graduates who can, as we say, hit the ground running so that we don't have to do training. And the other part, which a lot of times, smart people, professors, students have great ideas, but they need funding. So there needs to be a mechanism that how they can get access to funding. Okay, opportunities for Pakistan. I'm sure it's very much on the mind of all the people on this call. So I have a lot of slides on this, but I don't think that I'll have time to go through each one of them in detail. But I can tell you that there are huge opportunities. This is a global industry. So we obviously want people to be employed in Pakistan, and that's actually my first preference. But we know that if we don't give them opportunities, they'll go elsewhere. So USA, Canada, Europe are obviously big, attractive areas for people. I must say that, I don't have any preference for any. I think in Pakistan, we should not be very selective. We are at a very early stage. We are at the cusp maybe of this industry. So we should be looking everywhere where we can find opportunities, whether it's USA, Canada, Europe, whether it's in China, South Korea, Asia Pacific region. Good thing is that we have some opportunities and some startups have already started coming into Pakistan. So if we look at USA, they were lagging behind in some ways, but in the last few years, they've been playing catch up. Again, big numbers. The CHIP Act, I'm sure many people on the call know about it. But I think USA is obviously creating an environment which is bringing in like $1 trillion of investment over the next 10, 15 years from the foundries, from the big system houses. And for us, it's an opportunity for companies, for startups to get business, and it's for the fresh graduates to get jobs. But I must tell you, it's not that easy to get a job right away unless you have industry experience. And that's why I think it's critical that we have in Pakistan a startup system where people can get their experience. Either they start up their own company here or they go overseas. This is Europe. Again, it's this sort of the big picture is the same. Big opportunity for us, for projects and for jobs. Same thing for South Korea. South Korea is very interesting because they have a big market share, but it's more focused on memory chips, and they want to diversify. So that's why they are making big investments. Again, a lot of jobs. I personally have the areas, the geographies I'm highlighting. I've been lucky to get experience in all of these areas. So I think great places to learn and grow. China. So obviously the big giant, the growing giant, and they are into all areas, and they have, they obviously are in a way a little bit, focused inward in the sense of their industry. Part of it is the language, but I think as I said, we have a great relationship, friendly relationship with China. So Pakistan should surely look for collaborations and projects and study also. I know a lot of students are going to China and other locations. Okay, I don't know if there are any questions. I am, getting into the tail end of the presentation. So, Dr. Hassan, are there any questions?
So, Jafar, there are no questions yet. I think it's better to conclude, then we would take the questions.
Okay, sounds good. Okay, so I will quickly go through. This is my company. So, building bridges is critical. That's how, many countries in Asia Pacific region have really developed and advanced. I mean, Taiwan is an example, South Korea is an example, China, India, Singapore, you name it. So we need to build these bridges. And in our way, this is what we have tried. We are based in Islamabad. This is our office. I didn't really introduce myself, I've got some industry experience from US and also 4 years I've been in Pakistan. My background is VLSI. That's why you might find my presentation a little bit more hardware centric or chip centric. Dr. Faisal is the head of engineering. He's a UT Austin PhD, computer architecture. He's really running the engineering team hands-on. This is the big picture. Our focus is processors, from low power microcontrollers to high-end controllers, microcontrollers to mid-range, 64-bit in order to 64-bit out of order vector. So basically, we really want to be a one-stop shop. As I said, we are working very closely with the company in California. Our big focus is right now in terms of design, RTL design, verification, front-end implementation, back-end design, and we do performance modeling as well. So we have got 60 people, and in the last 2 years, grown from 6 to 60, so 10x growth. Alhamdulillah, we are doing well. So this is an area that I would like academia to help us. We train. We have like a 3 to 4 month training program. We train on computer architecture, C assembly, RTL. So these areas, we would really love the universities to have take these parts of our plate so we can focus on verification, physical design. That will really help us a lot. Our hiring focus is across the board from entry-level engineers to experience. And you can check our website, but these are some of the areas we are interested in hiring. Okay, so key takeaways. I think everyone knows academia, industry, and stakeholders. So the left-hand side of the slide is talking about, what are the things. These things are already done in universities. We really hope that they can be done to more sort of, greater level, more depth, and in a problem-solving mode. And the tools should not be considered a limitation. Open source tools can be used, commercial EDA tools. I hope the government entities can jump in because that's what they have done in our neighboring country and many other countries around the world. I think they can also, the universities should look at their second, third year program and see what elective courses they can offer, especially in the semiconductor space. MS program, many universities have started. That's great. Dr. San is one example. There are other universities, NUST and UT Law and others, LUMS. On the right-hand side, I'm talking about, what the industry can help. This is something that we are also working with different universities. We'll keep on doing that. Workshops are great. I think the stakeholders really need to facilitate and come up with some ideas. We should learn from the ecosystems around the world. This is not rocket science anymore. I think what we need is a focus, a longer term thinking and planning. And this is my last slide. I have no doubt in my mind that there is a time for us. This is the time for us to grow the industry here. And it's not as if that this will be in vacuum. There is a big need out there, but we need HR, we need scalability, we need quality people, we need professionals who can deliver, and leadership. I think we have all of that. We just need to put it together. I'm open to questions now.
Thank you very much, Sir Jafar. So, any question from the audience? He is one of the right guy to ask about the industrial prospect of this IC design in Pakistan. So I can see there are many freshers over here. So it's the right platform to ask the question.
I might add that, there are no wrong questions,
Yeah.
so feel free, don't be shy. चलें फिर
Okay, I
Yeah.
think that, yes.
जी
So
जी
actually, we are talking about AI and chip designing. So normally these are two different areas. Like AI is related to the software side, and the chip designing is hardware side. So how can we make these together, and how can we learn side by side to work in this way?
Actually, I think so. Who's the person who asked the question?
Rizwan, yeah.
Okay, so Rizwan, the thing is that yes, there's a big software focus, but if you look at the pyramid, right, the different layers of AI ML, it's not just software. The bottom part of that is hardware, and when you're running these loads, you need a very smart hardware too. What type of a processor you're using, how it's going to run though your algorithms for AI ML, what is the power envelope, what is the performance, what is the throughput. All of those things are not just software issues, they are hardware too. I mean, it's not a surprise that the largest chips are being manufactured by AI companies now. It used to be that Intel, AMD would be making the most complex chips, but now a lot of the AI companies. So it's a system issue. It's not just one area. And I think hardware, software are joined at the hip. I mean, that's the way I look at it from AI ML perspective. Obviously, the big focus is on the software side, but the software, why is Google and Facebook and Amazon, why are they building their own hardware, right? They are obviously a lot of AI. They are probably some of the biggest consumers of AI or AI related applications and products. It's because they know that if they have got customized hardware, it's really they'll service their market well. Their profit margins are going to be bigger. So I think it's all together. And AI is already, if I let's take the software side out, just the chip design part, AI is a big part of it now. All the top players are spending a lot of R&D resources to get the best hardware, which is suitable for AI.
Thank you,
Thank you
sir,
very
for
much.
your. Yeah, sir, I have one more question. Like, if you see in Pakistan, like in universities, so there is a big gap between the software and hardware side. So someone is working on hardware side, he never sees AI and these kind of things. He never get used to it. So what kind of suggestion you will give to students to get up to date with AI and also with the chip designing side up?
Okay, so I will say, I mean, this is what I tell when I go to different universities that, yeah, there is a big, like, there's a wall between software and hardware. I think that there probably needs to be more sort of, as you say, cross-pollination. I think the other part is that let's not worry too much about AI ML. I think let's get the foundation strong. Whatever, because a lot of universities I've seen that they've got the best courses listed on their in their syllabus, but some of the basics sometimes are not covered. So I think, and I'm not saying that there is not a need for not revamping, but updating the syllabus. But I think the key part is that if RTL design or digital logic design is being taught in a university, then Verilog and RTL design skills should be, they should really be, the students should really have a lot of projects that they can improve their skills. If they're doing C programming, they should be doing a lot of problem solving. if they are doing computer architecture or processor design, they should really be looking at hopefully, some new architectures, not x86. Assembly was probably out of practice. Maybe that should be brought in. So I think on paper, the syllabus is not too outdated. I think what is mentioned, what is listed should be done well. And, on the industry side, I can say that, we would help as much as possible, but everyone should keep in mind that industry has huge pressure to deliver products. So there are key areas that we can collaborate, but it's really sort of a partnership, or, as we talk about ecosystem working together.
Thank you, sir. That's your detailed response.
Thank you very much. Sir Jafar, there are a few more questions. There is one question from Ms. Aisha Amir. The opportunities you are talking about for fresh graduates, are those for the BS graduates?
Yes, they are. So actually, just a few weeks back, we hired a lot of engineers, trainee engineers, and about out of the number we hired, it was a big number. It was double digits, and about 15-20% were masters. All the others were undergrad. We do have a very specific test, which is the sort of an induction test and an interview. But we welcome new college graduates. Actually, the last 2 years, that has been our biggest contributor in growing the team. We would love to hire more experienced people, but we hire graduates. But I tell all of the graduates we hire that have some interesting experience when you bring your resumes to us, industry related. And internships should not be just for certificate, but learning should be the focus. But yeah, we are open to new college graduates.
Thank you very much. And then the next question is from the Mubashir Ali. What is the percentage of IC designing in your company in comparison with the verification?
So yeah. So we have got about 25%, 25-30% RTL designers. We have a big team of verification engineers, and that's not a surprise. A chip typically spends about 70% time in verification. And verification, so but just one clarification, verification is not just RTL. It's at gate level. It's verification at every step. It can be static, it can be dynamic. It's at every stage when the design changes, there is verification needed. There is obviously physical verification needed towards the tail end. So we have physical design team as well. We also have performance modeling. So the fact is that we want to grow. We want to have more people, but it's not easy to find people. So a big team right now is verification. That is very much in line with the industry needs. But I think we are one of the few companies that we are developing full-fledged IP processors, and yeah, we have a very strong RTL team as well.
Okay, thank you very much. And there are a few more questions that I am not sure that's appropriate to answer or not. So if you don't want to reveal those, then you can just skip those. First question is for designing which technology node you are using.
We are using multiple nodes, but we are a FinFET. And we also have access to very advanced nodes, so in single digits nanometer. So because this is what our customers want, so we are very lucky that we've been able to get access to very advanced PDKs across the board. So yeah.
And one more question in the same way is about the tools that you're using.
Since we are an IP provider, we are an IP provider. We use both Cadence and Synopsys, and
okay.
Yeah, we have full flows.
And there is one question from Mr. Ali. What do you see the future of design verification? Is it disrupted by the AI?
AI is complementary. I mean, AI is playing a big part in verification. I mean, I talked about, from a physical standpoint in terms of cell placement and floor planning and manufacturability, but verification too. So coverage is not a simple it's not that simple to have coverage, 100% coverage. There are many parts which play into it, and how to find the bottlenecks, how to do the root cause analysis. So AI is actually it's disruptive, but it's complementary. It's really yeah, I mean, we can get into a very long discussion on this one, but I think AI is complementary, an opportunity.
Thank you very much. So just take the last question. It's from Miss Rooj Mazhar. When we can expect your company to open up internship or job opportunities?
Well, we just we just did that, as I said. So we started this process in June. So we had a significant number of openings, but we were just overwhelmed by the number of applicants. We got like 620 something applicants. So I think the good news is that there is obviously a semiconductor wave going on in Pakistan. But the flip side is, I think some of the things we talked about, that the quality and the graduates, I think that are coming out. And I know that there's a big effort going on right now to improve that. So, and we are not the only player. I'm glad, actually. I think we need, at this stage, we need a lot more competition in Pakistan, so that, because it's a global market, if we have competition in Pakistan, then our talent will grow and we can get more projects and more companies will come to Pakistan. So I think, yeah, we just did that. But if someone